Hi class, welcome to Numpy lecture. We're gonna go over three different parts of Numpy. I'm gonna explain what each of the tools that we're gonna see in Numpy do, and we're gonna make it interactive through Colab. So please make sure that you download the file on your computer. So this should be an IPYNB file. And what we're gonna do is we're gonna open up that file, or we're gonna upload it to our Colab, our Google Colab. So you make sure that you open your Google Colab. I'm gonna open Colab, and then I'm gonna upload a file. So I'm gonna say upload notebook, and we're gonna sign in. So I'm gonna sign into my Google account, and then continue. So what I'm gonna do is I'm gonna upload from my computer, and let's see, downloads. So we have NumPy array lecture. So we're gonna open that one. And so this is what you should be able to see. We're gonna go over this content. So I'm gonna explain to you guys what each part is doing, so you guys gonna follow along. And so let's start with this. So I explained a little bit in the first lecture what NumPy is. NumPy is a library in Python that allows us to be able to interact with arrays. The reason that this is important is because Python by itself is a slow programming language. It is built in on a C language, and the way that a data type is like integers, strings, booleans are structure are set up. They're set up as a structure, not as a data, just a pure data type. So when you create or when you save something as an integer, you're not just saving an integer, just saving a data that contains an integer value. It actually contains more than that. It contains a lot more, like the location of it, where it's being stored, what kind of data type is, the size, and everything. So it does contain more information, more storage. So it's like a box that you're storing a integer value, but it contains more information about the integer value than you would in a C language. And for the same reason, so that makes it a little bit more, it takes more space and more time to process. So especially when you want to store a list of elements, right? You're gonna have, that's give you the flexibility of storing different type of elements in a list. That you could have an integer with a string, with a float, with a boolean, with another list, right? And you can actually store all in the same list. But that flexibility comes with a price. It makes it really slow, right? So NumPy, the library NumPy allows us to be able to translate some data, right? That it's all pure, they're all the same type. Like for example, let's say they're all type integer, and you can kind of like take away, like peel off everything that you don't need and just store the numbers. And that's what NumPy does. It makes it a little bit it makes it a little more efficient in the sense that it doesn't store that much information, right? It doesn't need to store that much information. and therefore makes it a lot more efficient to be able to manipulate, to play around with. So that's the idea of NumPy. So NumPy is a linear algebra library for Python. The reason it's so important in data science is with Python is that it's almost all the libraries in PyData ecosystem rely on NumPy. So a lot of the other libraries are built in, like Pandas. You're gonna know that in Matplotlib they're gonna be built in on NumPy. NumPy is also incredibly fast as it has binding to C libraries. For more info on what you want to use arrays instead of lists, check out the Stack Overflow post. We only learned the basic NumPy to get started with for our class. Installation instructions: it's highly recommended you install Python using an Anaconda distribution to make it sure there's underlying dependencies. For Colab, we don't need to do it. We can just do it with, that's why we're using NumPy, Colab, because you don't have to install the Anaconda, such as linear algebra libraries, or sync up with the use conda install. So let's see if you wanna, I'll give you guys an option here if you wanna install it in your computer, or you can also do PyCharm is another option. But if you want to install it on your computer, you can do it, and by using conda install it on Pi, and that would allow you to install NumPy. But we don't have to do it in our case. We can just use Colab to do this. So in order to be able to install to be able to work on it on Colab, all we need to do is import NumPy as np. So in here, what we're doing is we're installing this library into our platform, or into this programming file. And what we're doing is saying, hey, let's import this library. So now we have accessibility to everything that's inside this library, NumPy. And in the same time, we're gonna rename NumPy. So instead of writing NumPy all the time, we're just gonna write np. This is not a rule, but it's like most people do this. So we just refer to it as np. So NumPy has many built-in functions and capabilities. We won't cover all of them. Instead, we will focus on some of the most important aspects of the NumPy: vectors, array, matrices, and number generations. That's just to give you an idea. So NumPy arrays are the main way we will use NumPy throughout the course. So we're gonna focus on arrays, and then from there, eventually, we're gonna be able to explore that concept, or extend that concept to data frames, which is in Pandas. NumPy arrays essentially come in two flavors: vectors and matrices. Vectors are strictly one-dimensional arrays, and matrices are a two-dimensional. So a two-dimensional will be columns and rows, and a vector will be just one-dimensional array. So it's just practically kind of like a list. And so some of you are familiar with physics or calculus, and you might have seen some of these concepts already. So, but if you don't, it's not important. As long as you have an understanding of college algebra, basic college algebra, you should be able to have an understanding of one-dimensional and two-dimensional arrays. And if not, we're gonna cover that. So let's start with the first part right here. So I'm gonna show you guys how we can take a list. So we're gonna take a list and we're gonna turn it into an array. So my list is equal to 1, 2, 3. And now I'm gonna show you. I'm gonna print my list. So this is just what we did in our in the first. Oh, sorry. I need to run this NumPy. I need to make sure I not run NumPy, so that I'll install. And you can see now I ran this one as well, and it gives me the 1, 2, 3 list. But again, a list is very slow because it's actually storing a lot more information about the numbers that I contain. And the reason is because it allows you to have the flexibility of storing different data types. In an array, you can only store the same type of elements, so you won't be able to have that flexibility. But you're sacrificing the flexibility of having different types, but in exchange, you're getting the speed, which is sometimes, it depends on what you need, right? If you need speed, then you want to turn it into an array. So what we're going to do here is we're going to take my list, and turn it into an array. So I'm going to use my NumPy, which is my library, and I'm going to call a function that exists within my library, which is called array, and that array turns any list into an array. So I'm going to have my list, and I'm going to turn it into an array. So I'm going to run this. As you can see, now I have an array of 1, 2, and 3. And that makes it a lot faster. So now we can also turn a matrix into an array. So I'm going to have a two-dimensional list. So we can have a my matrix, right? So I'm gonna form it. I'm gonna create it as the form of a list by doing 1, 2, 3, comma 4, 5, 6, comma 7, 8, 9. So as you can see here, we have a list of lists. So the outer list has 3 elements, and those 3 elements are lists. So it's a list of lists. So each element is a list. So what we're gonna do here is I just created a list, and now you can see that if I print this, you're gonna be able to see that I get the same thing that I have in my answer. So I have my list of lists. Now this is a list, it's not an array, but we can turn it into an array by using the same tool, same function that we did before. So we have to use MP because that's the location where the array function is located. So we have to use MP, right? So to tell the computer, hey, look at the MP file or in the MP library and look for this function called array. And what I'm going to pass in is my matrix. So I'm going to pass in my matrix, and now I can run this, and you can see now I have an array of a matrix. So, and just like that, we have an array of matrix. So there's a lot of built-in ways to generate arrays. So I'm gonna show you some other ways of creating arrays. For example, I can make an array with just from 0 to 10. And so that's kind of like more like a vector, right? Because it's one-dimensional. But so here it is. So I can do is MP. So I'm going to look at the MP library, and I'm going to look at the method, the function arrange. So this arrange allows me to take allows me to take multiple input values, as you can see there. It allows me to have the start, the stop, the step, and the type, and the like, right? So I can, and it tells you here what each one does, right? The stop values are generated within the half open interval. So I can have from 0 to stop. I can have the step, the values generated within the half open. So it allows me to jump in. How often do I want to jump into the numbers? So if I want to have the number from 0 to 9, I'm gonna tell the computer I want to start at 0, and I want to go all the way to 10. So if I do that and I run it, it's gonna generate an array from 0 to 9. As you can see that. Now, if I put an extra value, like for example 2, what this is going to do is going to skip every other number. And you can see now I have 0, 2, 4, 6, 8, just like the way we did it for list. But I'm going to keep it the same and just keep it from 0 to 9. Notice that the last element is not included. So just remember that. If I want to, here's the example, right? If I want to do it all the even numbers from 0 to 10, then I would do MP. Again, that's the library. Arrange from 0 to 11, skipping every other number. And I can run this, and now I have 0, 2, 4, 8, 6, 8, 10. And so now what we're going to do here is generate an array with just 0. So I can actually generate that by using, again, the library NP. That's the location where the function is going to be located. And there's a function called zeros. The function zeros inputs just 0 elements. And I'm going to say how big this array is going to be. So if I just want to have an array of one dimension of size 3, then I'm just going to put a 3. So that means that I just want to have one dimension. I run it. and I'm going to have 0, 0, 0. So 3 zeros, this is just one dimension. But if I want to have a two-dimension zero array, then I'm going to use MP zeros, and then I'm going to say the size. So if I want to have a size 5 by 5, so in other words, a 5 rows, 5 columns, then I'm going to do a 5 by 5. So I can change this to 3. And then you can see that this is going to be the number of rows, this is going to be the number of columns. But they're all going to have zeros on it. So that's if you want to have a zero matrix. So sometimes this is very useful in linear algebra. If I want to have ones, I can do the same thing by just having, instead of zeros, I can have ones. Again, very useful. And I'm going to have 3. So this is just going to be a row of ones. If I want to have a 3 by 3 ones matrix, I'm going to do 3, 3, comma 3. And that's going to be a 3 by 3. And then let's do, there's another way of creating an array, and that is by evenly distributing the numbers. So for example, if I want to have 3 numbers that are evenly separated, then I can use a method called line space. So I'm gonna, again, it's located in the MP library. I'm gonna use lin space. I'm gonna say that I want my numbers between 0 and 10, and I only want 3 numbers in between. If I do that and I run it, it's gonna give me 3 numbers that start at 0 and end in 10. If I want to have 4 numbers, then I can put 4 there, and you can see that I have 0, 3.3, 6.6, and 10. Okay, so that would be starting at 0, right? Starting at 0, that's my first number. My last number is going to be 10. So in other words, that would be like I have to distribute the other 2 in between those numbers. So if I have 5, right, then that would be a even distribution of a 2.5, right? So you have 0, 2.5, 5, 7.5, and then, right, because the 0 and the 10, the endpoints are included in this case. Okay, so this distributes the number from 0 to 10 in an even space. Okay, so I'm going to put back this 3, just because that's how I have it in my notes. And then we can do it for more numbers, right? I can do np dot line space, and I can do from 0 to 10, and I can have 50 numbers, right? If I want to have 50 numbers, I'm going to have the 50 numbers from 0 to 10, and they're all even distributed. So there's the same distance from 0 to the next number, and to the second number, and from the second number to the third number is the same distance, the third number to the fourth number the same distance, and so on and so on. So that's if you want to distribute the numbers evenly. If I want to have what we call an identity matrix, we use the I function. So we're going to use, again, MP, because that's where the function is located in the library MP. I'm going to use I, and I'm going to say what is the dimension of my identical matrix. So because an identical matrix is evenly, it has the same number of rows and columns. So this, I don't have to specify 4, because automatically has understood that it's going to be an identity matrix. So I can just write 4, and it's going to create an identity matrix. An identity matrix is when you have a diagonal line on all ones and everything else zeros. So that's an identity matrix. And then what we can do is we can have a little more fun than just, this fixed numbers. We can actually have random numbers. So Python allows you, or Numpy allows you to have a random number. Python by itself gives you random numbers, but Numpy also has a way to generate random numbers. So if I want to generate an array with random numbers between 0 and 1, then I can use what we call a rand. So a rand will create numbers, will generate random numbers between 0 and 1. This is very important. It's going to be between 0 and 1, not including the 1. So if I want to generate two random numbers, so I would do MP, because that's where the function is located. It's going to be a random number, and it's going to be rand. So rand by itself is going to give us two random numbers. So it's probably going to generate a different number from here, but that's fine because it's just going to be a random number. So you can see it's going to be between 0 and 1. Now, technically, there's no such thing as a random number. There is a formula that they generate to be able to generate random numbers. So if we want to be technical, because it is based on an algorithm, technically it's not a random, right? But it gives us the appearance that it's a random number. I can generate random numbers on a 5-dimensional, right? Not just one dimension. So what we can do is we can do np.random.rand, and now we can say that it's going to be, it's going to be 5 by 5. So it's going to be a 5 by 5 matrix of random numbers. So you can see here, this is one column, another column, and so on and so on. And we have a 5 by 5 matrix. So we click on it, and you can see they're all between 0 and 1, not including the 1. Now, there's another way of generating random numbers, and that is using a standard normal distribution, where the mean will be at 0 and the standard distribution will be on 1. So this is going to give you a possibility of having negative numbers. So okay, so this will return a sample or examples from the standard normal distribution, unlike rand, which is uniform. Okay, so here we're gonna use the same. We're gonna use np again, and random dot rand, and then in this case, using just rand d is going to be rand n for normal. And what we can put here, we're going to put the size that we want. So because I'm putting only one number, it's just going to generate two random numbers from my normal distribution. Again, the mean is going to be at 0, so the center is going to be 0 with this distribution of 1. And so you can see here that we get those numbers. And if I click it again, it's going to give me another number, and you can see they're negative. So as you can see, it's going to be at center is 0, and it's going to range from -1 all the way to 1, without including -1 and 1. We can do the same thing with a 2-dimensional matrix. So we can do np.random.rand and I can do a 5 by 5 random distribution. As you can see, we generate those random numbers. And we can also do integers if we want to. So it does give you the tool for that. So I can generate just a random number by doing a random dot rand int, and so this is going to generate a random number between 1 and 100. So you generate 19, 53, and I can actually generate a matrix, an array, using this rand int as well if I want to. So I can say how many elements do I want in my matrix. If I want to have 10 elements, random 10 elements, so I can just specify that I want 10 elements. So this is going to give me an array, a one-dimensional array with 10 elements. Okay, and so we can also generate, you might think, well, what about if I want to have a matrix, if I want to add if I want to have a matrix of random numbers, of integers instead of decimal numbers. So well, we can do that. And what we can do is we can add another code. So I just want to show you, right? I'm going to generate a second one. And I'm going to specify the dimensions. So instead of being a 10 dimensions, I'm going to say this is going to be a 10 or a 5 by 5 matrix. And you can see that it generates a matrix, a 5 by 5 matrix, 5 rows, 5 columns, with random numbers between 1 and 100. And so now there are attributes that the NumPy array has. So an array has attributes and methods. So what we're gonna do here, so right now all we did, we're transforming, we're using functions to transform, to create arrays, right? So all we're doing right now, we're creating arrays. We're creating an object of type array. You can literally see this. This right here is an object of type array. This is an object of type array. It is telling you right there. This is an array. So it's an object of type array. So all we're doing right now, we're just creating objects of type array. Now, the arrays have attributes and methods. So now what we're going to do is we're going to be able to use some attributes that are specific for arrays and method as well. So for example, let's create an array. I'm going to call it R, and I'm going to say np.arrange. So I'm creating an array again. I'm creating an array, an object of type array. So this is an array. I'm creating an array, and I'm saving an RRR. Okay, and I'm gonna create another one. I'm gonna call it rand R array or R. So again, I'm gonna create this object of type array, and it's gonna go from 0 to 50, and it's gonna be a size 10. Okay, so again, this is gonna be a one-dimensional. This is going to be a one-dimensional array from 0 to 25 or 24. This is going to be a one-dimensional array from 0 to 50 with 10 elements, random elements from 0 to 50, but just element a size 10. So if we want to see them, right, we're gonna be able to just, sorry, I had to click run here, and now I can click here. So you can see here that this is just an array from 0 to 24, and this is gonna be a array from 0 to 50, but only 10 elements, and they're gonna be random. So if I do rand rr, they're gonna be random elements, right? 10 of size 10. So that is just again creating an object. So there are two objects of type array. And so what we're gonna do here is I'm gonna take this array that I have here, and I'm going to change the dimensions. I'm gonna reshape it. So instead of being a one-dimensional array, I'm gonna make it into a 5 by 5 dimensional array. Remember, I have 25 elements, so I could take those 25 elements and put them in a 5 by 5 matrix. Why? Because they have the same size. So I can reshape them. So I can say I can take the rr dot reshape, and I'm gonna reshape my R, right, into a 5 by 5 matrix. So I'm gonna take this one-dimensional array and turn it into a 5 by 5 matrix. Okay, so if I do that, you can see that there is now rearranged. I could do something similar to this one, but it has to be something that is divisible by that. So I can take that one. Let me put here. I'm gonna add another code, and I'm gonna take the rand R, and I'm gonna reshape it to something that is that it has the size of 10. So I know that 2 times 5 gives me 10 elements. So I'm gonna do 2 and 5. So that's gonna rearrange my 10 one-dimensional array into a 2-dimensional array where it's gonna be a 2 rows, 5 columns. So you can see right here that it fits. But if I put this as a 3 here, then you're gonna see that it doesn't fit. It says there's no, the size 10 does not fit in a 3 by 5. So it doesn't know what to do. But if I put 5 here and put 2 here, because 5 times 2 gives me 10, it's gonna allow me to reshape that array. Okay? And let's see. As you can see, it's only making a copy of it. It does not change it. That's not, and that's good. That's good that you don't wanna change your array when you apply this methods. The reason is because you might not want to change it, and so it's easier for you to make sure that if you want to change it, you have to do something extra. If I want to change this to a if I want to change my array to permanently be a 5 by 2 matrix, I would have to resave it again to it. And so if I do that, and then if I run this again, you can see now this is changed. But that only works if you actually resave it back to itself. But I don't want to do that. I want to keep it the same. So I'm going to go back and run this again, 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 and then run this again. So that way I can have the same thing that I had before. Okay? But note that if you want to change it permanently, you have to resave it back to itself. All right. And then we can talk about some other methods like max, min, argmax, and argmin. So again, just to see what we have, I'm gonna print my ran array, and then I'm gonna run my array.max just to find the maximum number on my array. So this is gonna look for the maximum number in my array. So that's pretty cool. I don't have to do any for loop to be able to find it. It can just give me the solution. And that's the advantage of using a NumPy. It does, since this is all the same data types, this is gonna already built in a very fast way of finding the maximum number. So if I run this, it's gonna give me my 47. And I can find the minimum if I do, or actually it can give me, I can find the location of the maximum by doing a ran r dot argmax. So this is going to give me the location where the maximum element is. So it's located at the third index. So this is index 0, 1, 2, and 3. So it's located at index 3. And then we can do ran r dot min. And that gives me the minimum, which is the first one, right? The first element. And I can do ran r dot arg min, and that's going to give me an index 0. Okay. I can also know what the shape of the array is. So this is going to be attributes. They're not methods. So you're going to notice that in this case, I don't have to put parentheses because they're an attribute. So for example, r.shape gives me the dimensions of my array. If I do reshape, I can reshape my dimensions into a 1 by 25. That's a method. And you can see it turns it back into a one-dimensional array. And now I can actually, I'm actually changing this dimension of my array into a 1 by 25. Being more specific to say that this is a 1 by 25. And you can see here that if I run my shape now, r dot reshape 125 dot shape is going to give me 125. And if we want to, we can change the dimensions by doing r dot reshape 25 by 1, and then